Hey folks, I'm just going to go through homoscedasticity of the error term. So just to be clear, it just refers to a constant variance in our error term, okay? So we have this little regression here. We're finding the effect of education on wages and regression. Say this is actual. Y hat predicted is represented here on the regression-ish. But this is actual. That's our error, obviously. Now, homoscedasticity states that the variance of these error terms must remain consistent across all levels of education, right? So my errors will look maybe like this. They remain roughly in line. They don't have to be precisely at every single point. The error is not going to be the same every time. Otherwise, we could perfectly predict it. But they stay in line roughly. So variance does not change across all levels of education. Okay. So say we violate this assumption and we have what is called heteroscedasticity. Heteroscedasticity, that's a big word. We have inconsistent variance within our error term. Okay, so we have wedge, edge, same as before. This time though, our error terms vary, okay, and they vary across education. They vary with education. So one possible example could be with low levels of education, the error term is quite small. Okay, so it's small, it's pretty damn close, we're nearly there. The regression's doing a good job. But as we get further along our x-axis and we have an increase in education, our error term starts to balloon out like this. Okay, I can't really draw it above that, but we have an increase in the error term, okay, as we increase our ed. Now, that's a violation. If this is violated, we no longer have a best linear unbiased estimator, and yeah, it's not ideal, obviously. Just quickly, another way to graph this is commonly as such. So what we do is we graph the error term, so say epsilon, against our x-axis education. And we don't want to see a line like this. We don't want to see an increase. We don't want to see a relationship between epsilon and education. Yeah, because this implies that as education increases, epsilon increases. That's violation of our blue assumptions. What we would much rather see, so this is hetero. What we'd much rather see is consistent epsilon for all levels of education. Okay, so that's our error. That's just another way of kind of visualizing this thing up here. And I found this kind of helped when I was learning about homoscedasticity. Yeah, so this is how. Yeah, so that's kind of it. Nice and straightforward. Hopefully that's helped you guys. Okay, thank you very much.